Hello guys, welcome back. In the last video tutorial I've shown you what was the main data that I obtained from the robot and from the sensors. Now in this video I will try to explain to you a model that I created in order for me to always know the orientation of the sensors and which calculations I made and which conclusions that I took. So okay, let's get started. The first thing that we need to understand is this image. This image represents the position of the elements that I measured. In this case we can see X, Y and Z. Those are the axes that record the positive values of the acceleration in the sensor. And we can see that the camera is skew aligned with the Y-axis. Now the first idea that I had was that if I would be able to find three angles that could describe the position and the orientation of the sensor in the three-dimensional space relative to the gravity, that will tell me all the time how the sensors are orientated and how they are orientated between themselves. The purpose of this is that if I know how the sensors are orientated and I do know where they are placed on a robot, then I could check on 20 times a second or 30 times a second or 50 times a second to see if the robot is moving or not, if it is falling or not, and I can try and correct that unexpected behavior. So basically I thought that I could have three angles and each of these angles would tell me the rotation in a certain axis. So in the first case we can see the z-plane. As we can see, the sensor is at the 0 degrees position right now, and using the x measurement of the gravity and the y measurement of the gravity, I could usually basically calculate what angle does the sensor has with the force of gravity. The calculation for the y and x angles are very similar to the z one. In this case y, we see that the angle, we can calculate the angle using the magnitude of x, and using the sign of z we can know in which quadrant the angle is. And for the x-plane, for the x-angle, the procedure is exactly the same. However, in this angle we will use the magnitude of z, and we'll use y in order for us to determine which quadrant, in which way is the sensor moving. So one of the first problems that I encountered while doing this data analysis is that, as you can see in the image, even though the sensor has two opposite positions, since the sensor is only rotating in the axis of the gravity, the behavior of the accelerometers is still the same. What I mean is that even though it is rotating, the accelerometers cannot detect this rotation. So I cannot, from what I can see in this experiment, I cannot tell only with the accelerometers the position or the orientation of my sensors, at least using the model that I created. The conclusion that I got from this analysis is that I cannot have the exact position of a sensor. What I can have is a circular area where the position probably is. Before I show you my result in MATLAB, I will try to explain to you a solution, a possible solution that we can use in order for us to avoid this problem. However, it is a very abstract solution, so I'm not quite sure this solution will work until I try it. However, my money is that it will not work, and even if it does, I do not think that this is the most efficient way. So basically the solution is to put three sensors oriented between themselves in order for that different axes can feel the effect of the gravity. And I don't know, however, if that will solve our problem, but Even if it does, it will mean that in order for us to have the orientation of one sensor, we need at least 3. So if we think that we might, for instance, use 9 as sensors in the robot, that means that we will need 27. So I do not think that this is a way to go. So I will show you now my MATLAB results. So this is the script that I used in the last video, the MATLAB script that I used in the last video. This time around I changed this true to false in order for me to not see again all the graphics that I've shown you before. So when I click run, there will be 4 subplots. The first one will show succeeding frames of that the camera has recorded during the experiment. The second subplot, the upper right, will show the values of the accelerometers of the measured by the sensor. And the third, the down left graphic, will show the angles as I told you and as how I taught you how to calculate them in this video. And in the last graphic there will appear the Euler angles that I will speak of in the next video. The main thing that is important to remember for this video and for the generality of what I do is when I use 3 curves, and that will happen a lot, XYZ, 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 I always use the calls RGB in order to make it easier for me to interpret the data. So in this case we can see that the R is the X sensor, the measure of the X sensor, the green G is the Y sensor, and the blue sensor is the sensor in the Z axis. Okay, and in this case, in the orientation, it's a little different. We go from plane Z, plane Y, plane X, meaning that the plane Z, the Z angle that I told you about before is this red line, the Y angle is this green line, and the X angle is this blue line. This you can forget for now. As you can see, this is what we measured, and this is what we obtained. Honestly, I looked at this angle the first time and I thought, okay, they are a bit messy, but maybe as I will try to rearrange them, the 3 of them, I will make the rotations one by one, maybe these can be correct. So what I tried to do next was create a 3D model that I will show in a second, a 3D model representing the sensor and how these angles affect the sensor. So let's look at that. We can see that this is not the behavior that we were expecting, or at least I wasn't. It was when this happened that I stopped a moment to watch, and the first thing that I did was trying to see if there was some kind of error in the code, because I was so certain that this would work. However, it did not work, and after I've seen this and found out that there was no error in the code, that was when I tried to study the case a little bit deeper and found all the problems. So in the next video I will try to tell you a little bit about Euler angles and how we can use them in order for us to solve the orientation problem. So thank you guys for watching.